Discussion about the homework. Homework 2, discussion.
What's your recommendation when you render billboards, but they're very low resolution?
Just because they are far, far away, or because of bugs?
I think it's bugs. I definitely think it's because of bugs. But I don't know. Have you experienced a bug like that before?
I would think that you put, I'm talking out of, I'm guessing, you placed the camera plane not in the right direction. Oh, right. Because I gave two options. Either you keep the distance between the pixel one, and then the distance, it should be much further away. The distance between each pixel and the nearby pixel is 1, which is the least common way for me. It was a nice first time, because then I can index the pixel as integers, or you're placing the image plane so its width is 2, namely from -1 to 1, -1 to 1, and then the distance is just 1 over tangents half. My first guess is that you are somewhere between the mixers, so you placed it very far away, and now you have very few rays that actually hit the billboard. And probably the easiest thing is to replace a billboard and try with lower resolution. That would be my first guess, or increase the resolution. But I can take a look and see. I don't know that I have much to contribute, but I can try.
So the problem is, it says in the document to submit before the project, you just
Only,
do it all together?
Submit all together unless you want me to say your math is final. That's why I try to phrase it, so I can debug it before you actually go ahead and program it. We have very little to talk about various mesh databases, data structures are not that different. And then we are in the very, very important chapter that talks about hidden surfaces removal, which would be a bit binary space partition, painter algorithm, and much more into Z-buffer algorithms. Of course, we start to realize that graphics are not happens naturally on single CPU. Okay, so the discussion from last meeting was revolving around the point that here is my triangle mesh. Here is a vertex V, and V lies in 4 triangles. And I do not want to maintain all the information that's stored with V multiple times. Right? That makes sense. And that's why we said every vertex, let's go back a few slides, many slides, that we will have one list of vertices, vertex 1, vertex 2, that just from the OBJ file. You are referring to the vertices as 0, 1, 2, 3, and so on. And now faces, which are just a triangle, tells you who are the vertices. And you think about this triangular mesh as a scheme of an object, which means that every triangle, when I visit, I'll redo the vertices in a counterclockwise order. So when I tell you that it's vertex 1, 2, 3, you know at which order they appeared. So that would be one way to support it. And once you are manipulating the database, maybe you want from the object file to build auxiliary other data structures. And in the near future, we will spend much more talking about, just sound check, all good. We will talk much more about geometric data structures, or graphics data structure, like how can we use hashing to do fast point location and nearest neighbor location. I'm at this point of the video game, who are the neighbors near me, or the objects that are maybe in my visibility region, and so on. We'll talk about hashing, we'll talk about quad trees, we'll talk about R trees and KD trees, all in the same family. At the moment, for the mesh itself, we are still not discussing any hierarchical data structure or partition data structure. That's in the format like we don't have information about the edges in the OBJ file normally. So, and we can represent the edges in a few ways depending on which queries we have in mind. Just to mention triangular strip, it's another way to tell you about a triangular mesh. So I'll pretend that my whole mesh consists of a list of triangles where coming in a sequence, 0, 1, 2, 3, and after the first and the second, 0 and 1, shares an edge, and the edge that I'll share will be the last one that I reported. It sounds much more complicated than it should be. So I'll tell you about the triangle P0, P1, P2. The order matters. And then in this triangular strip, I'll just tell you about one more vertex, P3. It's the fourth vertex, starting at 0. And you understand from it that you need to take the last two vertices that I reported, P1, P2, add to it P3. And now the last two vertices that are reported are P2, P3, and I'll tell you about P4, just one more vertex, and so on. So instead of telling you the list of all the vertices, just one more vertex in each time. Okay? And some of you, I think, went to Joe Mitchell's talk that was about a month and a half, 2 months ago. I had a visitor, Joseph S.B. Mitchell, that these pretty central computational geometers, and he earned for Stony Brook, to his universities, a very, very substantial amount, having a patent about taking whole triangular mesh, the whole scheme, and break it into a small number of such strip, because obviously such a strip is very economical, and then I need to start another strip, and for the other strip, the first triangle I have to report all three vertices. So the fewer strips that I can have, like in the extreme, each triangle by itself will be its own strip, which means that I need to report the same edge twice, the same vertices. And here I don't report just the indices. I report the actual location of the vertices. So at this part of computer graphics, Sun ecosystem was very keen about really saving every bit, and that was quite substantial, this factor 2 that you can save.
Excuse me.
Yeah.
So in the previous one, to identify the next pair of the next triangle, if I drew the first triangle, so I need to know which face would be closest to the next point that I have to pick up, so that I know which side of the triangle that I actually create the second triangle.
So absolutely, the order absolutely matter, and it's up to you. And you're telling, say, OpenGL, many other, I've seen it in many other contexts, but OpenGL would be the first example, and you declare, I start a triangular strip, and you'll understand that the first three vertices, you're reporting a set of vertices, but the way, without having this agreement about how the triangles are touched, it can be interpreted, could be understood in multiple ways.
Oh, I was trying to do cross products, but so if you give it in this order, to get the normal to triangle 1, we have to do P1 to P3 and P1 to P2, which would, I feel like, implies you take the previous triangle, or the last one of the two that you're saving, the oldest. And then, but if you do the same thing with P2 to P4,
P2 to
It would
P4.
reverse the orientation.
I always take the last three vertices that I reported.
Yeah.
That's a file I managed to save in a clean way. You always look at the last three vertices that you reported, they form a triangle. And any new vertex, just add one more triangle.
Yeah.
So had I need to report this triangle from scratch, I had to report at least. I'm saving just one vertex per triangle that I reported.
I guess what I mean is, do you alternate the order you're using to generate the normals? Because, for example, if you do P0 to P2.
Oh,
P0
you're talking about clockwise versus counterclockwise. Yes.
You flip every triangle.
You do. Does not follow the agreement of the agreement of reporting them in the counterclockwise. You're absolutely right about it. So, good point. That the normal, it does not preserve this agreement that I insisted that we always maintain.
Don't you just work backwards from the newest added vertex though? So you start P0, P1, P2. The last two are P1, P2, you got P3. You work backwards from P3 to P1, and then that would be your cross product. And then you still maintain the orientation as you step through.
Yeah, it's doable. This representation is a bit archaic. It came up from the point where bandwidth and reporting, transforming the mesh back and forth from your monitor was a huge bottleneck. And saving one vertex per triangle was worth the extra work that you had. Okay, so far for this triangular strip and how much we are saving. Yeah, and you have to start a list of strips. And I'll think about your point and I'll see if I have something more intelligent to say. Okay, just to mention, you can also report to OpenGL, for example, triangular fan, different from triangular strip, and then you'll understand that these triangles that you're reporting, again, you're adding one vertex at a time. Right about it, you're reporting P0, P1, P2, and now you'll understand P3 not as taking the last two vertices reported, but you'll understand that all these vertices, all these triangles shares the first point that I start. So I start from the common point of all the triangles, or sharing a vertex, the first vertex that I reported. And now after reporting P1 and P2, P3, you'll take P3, the previous vertex, and the first one. It sounds extremely confusing when I'm putting it in the words. The picture says everything. Here I have one vertex common. Previous slide, I had a strip of triangles. Okay, and you just declare it once you tell OpenGL. My shape consists now of render for me the following triangular, say the word strip or fan or neither. Okay, queries on meshes. For a face, I'd like to know who are all the vertices of this face. For example, I landed in one triangle, I did ray shooting and I hit one triangle. I want to know who are the vertices of this triangle. Or in homework 2.3, it would be who are the vertices of the billboard. What are the edges? And more relevant, what are the adjacent faces that I definitely want? Say to do. Why do I want adjacent faces? Easy question.
The normals, so you can figure out
the approximated normals.
Yeah.
When I'm using the Phong interpolation method, I need to take the neighboring faces to average the directions of the normals. One of many applications. Okay. For a vertex, find all the triangles that this vertex participates in. that are there, and who are the neighboring vertices, and so on. And if you just look at these queries in the OBJ file that we describe, it's quite hard to answer it. So there are a few variants of it. They describe, and essentially in computational geometry sometimes we talked about DCEL, doubly connected edge list, and there are a few variants of it that we'll see now. We need three types of structures. We need a structure for that will be either triangles or in general faces. How many faces do you see in this picture? Right here, I'll clean it. No. Four, and you say?
That's
Good.
good.
Somebody have different ideas? So formally, depending if you want to report it or not, but formally there are five. There is outer face and four triangles inside. So sometimes you care about it, sometimes you don't. If you are on describing something that lies on a sphere, there is nothing special about the outer face. It's just a face like any of the other faces. If you are on a cube, same thing. But I can draw triangles on this object, defines, just draw triangles. You have a triangular mesh, and there is no such thing as the outer face. Each face is the outer one. If you don't believe me that it's the outer one, we are using the orange peeling algorithm. We are saying here we draw the triangular face, and now in every face I stick my nails in and I pull it to the side and make it, fold it to lie on the plane, and you see that the face that I started with by stabbing it became the outer face. So there is nothing special about it. So you have triangle or a face, and sometimes I want all the vertices. If it's a triangle, it's not a big deal to store all the faces. I'll just mention that another geometric object that is sometimes useful, less so in graphics, at least not in the rendering, more in many other applications, would be just a planar map. So I still have faces, F1, F2, F3, F4, and if I want the outer face as well, every face has vertices and edges around it. Same deal, it's just not triangles. I can always add more diagonals if I need to make it a triangular face. But used to be popular in graphics, but out of fashion to talk about quads instead of triangles. So maybe I'll add all the vertices explicitly, maybe I don't need to. In this variant, sure, I will store all the vertices per face, again just the indices of these vertices, and I need another array of edges. So altogether, in any of the data structures, I have 3 arrays, one for edges, one for faces, one for vertices, and the idea is that every bit of information hopefully stored only one. Pointers may be indices into the arrays, maybe stored more than one. Everything that specifies the location stored only one. Vertex, here is a problem. Vertex can be on a lot of triangles. Maybe we'll store for every vertex all of them. Maybe it's enough to store only one. I'll show you more economical ways. An edge, I'll tell the edge what are the 2 vertices, and why do I need 2 places here? Because it has 2 faces adjacent to it. And I probably want to be a bit more organized about which edge is which. So again, skimming a bit through it, if I want to go from one face to the next face to the next face to the next face, walk along the triangulation, then I can have, again, the vertices for each triangle, each face, and I need to store pointers to the three neighboring triangles. That's a bit ugly. It's a bit wasteful. It would be easier for each vertex to one of its adjacent triangles. And the highlight here, the degree of a vertex might be very large. I can add more edges, and it geometrically happens a lot. Think about a pyramid, one vertex with very high degree. It's enough that the vertex will know what's of its adjacent edges or its adjacent faces. We'll see in a moment how. And, yeah. So I can store, let's even jump over this one. I can store for every edge. Let's get to it. I can go get for every edge. It will be enough if I'll tell you for the edge. It will have a direction, and I'll tell you for the edge what is its tail, what its head. And what's important about it, if I'm standing outside the shape, looking at the shape, then the edge, think from tail to end, then the left and right direction are well defined. Right. And in the left direction, I'll tell you what is the next edge in which order, counterclockwise always, next edge in which order on the left side, previous edge, good. And there is a bit too much information here. I can use less, but that's at least relevant. And similarly in the right, what will be the right edge, the right next, and the right previous. Okay. Now, where can I save something here? How can I find the previous if I just have the next edge? Well, if I think about this edge, and I'll tell you, this edge will go in this direction because I'm going counterclockwise, and this edge will go in this direction, following it in a counterclockwise order. Then by just following the next, I can discover all the edges around it. Okay, so edge stores pointer to the head and tail. Pointer as vertices in the array of vertices, as usual, not the vertex itself, just what's the index of the vertex. Next, and previous edges. Okay, and how can I get from how can I discover all the edges that touches V? V over here in the center. What V needs to know? V needs to know about a single edge that leaves V. A single edge that leaves V. How can I discover the other edges? I will go from this one edge that leaves V to the other side of this edge, which lies on the next face. Go to the next, revisiting V again, go back and forth throughout the edges, and in this way I can rediscover when do I close a cycle. So one edge is enough, and just the next one is enough. So the correction, because they are both in counterclockwise, of course, then the prev will be I'm not entirely sure. I'll get back to this point if I want to correct. Winged edge, did not realize this difference. Yeah, you'll have the next and the prev carefully, and that's now you can find for an edge who are the faces that touches it. You know which one to lay the left, which one of the right. Of course, depending how you stand on the edge, but once you decided about one direction, then you can discover the rest of the edges. Correct? All the half edge will be that every edge will be just, I'm taking an edge from U to V, and I'll give it a direction. This edge E lies, as usual, in two faces, and now what do I know? In each face, I'm moving in a counterclockwise order, meaning, and now I can replace E by just saying, let's switch one normal edge into two twins half edges. So E1 and E2 are becoming two twins half edges. And now, what does a half edge needs to know? It needs to know its what is its twin? What is a twin half edge? So E2 should tell me my twin is E1 and vice versa. There are two sides of the half edges, but notice they have different directions, and each one is associated with a different face. It should know at which face it is. Of course, each twin edge needs to know at which face it is. What else does the edge needs to know? The half edge needs to know. Now we are trying to be economical, to be low on memory.
You know how many vertices it has to traverse to get back to itself?
So I need to know the face. I need to know the next half edge, which would mean that E2 will know about E3 as its next, and E3 know about its 4 as its next, and so on. So I don't need to know the numbers, but by following the half edges from next, I'll be able to go back to E2, and that's, I'm closed all the edges of this face. What else does a half edge needs to know? Something about the vertices it's associated with. So what else do I need to know for each edge? Again, trying to be economical.
What do you need to know this? I guess you give a direction, you have to know the starting vertex and the ending vertex.
Origin vertex. Each half edge needs to know its origin. What other vertices does it need to know? Oh, does it need to know its target vertex? Again, trying to be economical. Go to the next and ask what's the origin of the next. Or, alternatively, go to the twin and ask what's the origin of the twin. Okay, makes sense. And as before, a vertex needs to know about one half edge that leaves it. Each vertex needs to know about one half edge that leaves it, and each face needs to know about. We said it might save time if I'll keep all the edges with a face, but if I'm trying to save memory, all I need to know about for a face, what I want to know is one half edge, I don't care which one, in this face. The index, the number of one of the half edges. Because once you tell me that inside this face, E2 is one of the half edges, I can discover the remaining half edges. And I can discover all the vertices by checking each one, what is its origin. Okay. And we can go more into nuances, but it's really trading a bit memory versus a bit time. Let's talk about hidden surfaces. Yeah, so. So from time to time, I'll discuss depth, and from time to time, I'll discuss distance from the camera, and from time to time, I'll discuss the Z buffer, and, which is in this chapter. And I'll assume here that the direction of the camera is into the negative Z direction. That is W, usually is just the positive Z. And we discuss how I'll arrange everything and what the matrix says in transformation that gets me to this property, but that's, you kind of already know. It's translation plus rotation. Move the camera to the origin and rotate it, or the other way around. And it will arrange it for you. What will be much less obvious is that I'll assume that I'm talking about orthographic projection, mostly. That's later in the chapter, not in the painter algorithm. But later, I will assume that all the objects are, or that I only care about orthographic projection and not perspective ones. And that will be much less obvious. How do I get, why can I make this assumption? Okay, so one object occludes another one, creating, and we need not to render the part that is occluded, assuming everything is opaque. That's how you get the feeling of depth, one of the ways. To create the feeling of the depth, you already know these slides. For every triangle, I'll assume that the vertices are given so that n, this way, points to the outside, and that by knowing that the normal points to the outside, that is, the vertices appears in counterclockwise, or that I can generate the normals by this object, I can already avoid rendering a lot of the triangles. I'm mentioning it a lot many times. That's the back face. Cool. How not to render. And again, you and OpenGL, WebGL just set a bit to say, I want to use this property or not. When will you not want to use this property? The backface cooling.
If you're like inside an object, then you'll...
Inside an object. Yeah.
Like if you're in a
yeah, no,
right?
you're absolutely right. I just didn't think about it, but you're absolutely right. So, more answers, just because it was not the answer I was thinking about.
Maybe if the object has some form of like reflective quality, so if the directional light's hitting the back of an object that you can't see, you need to still...
Excellent point. If I have mirrors, absolutely right. Mirrors, yeah. The mirrors will need more than just a Z buffer, but because that's where I mentioned we need to decompose a mirror's texture. Another example, well, the example that I had in mind is, of course, if the object is not opaque, that you do see part of the other side. Maybe you don't want, you want at least the mesh, the wireframe of the backside, which you would not see otherwise. But other than that, it's just a way to save lots of time. Okay. Yeah, backface culling and just render the thing that there is chance that you'll see, just a part way to mention it. Let's talk about depth thought. Sometimes I can just tell you that there is some order, maybe not unique order, but there is an order that I can generate all the hidden surfaces, remove all the pieces by using the painter algorithm, which will be first sort and now now render them according to this order, and don't care one bit about which part is occluded by another. It's all encapsulated in the order. How can we do it? Once I have the order between these objects, let's say, sort them by distance from the Z direction, distance from the camera, I will render them based on render first the most remote one, the one that is furthest away, quite similar to what you were discussing. Then the one that is a bit closer, but once I render the red one, because it's closer to you, I completely ignored for each pixel. How do I render the red one? Just render each pixel, the color of this object, and I don't care what it was before. So if it was white or it was gray earlier, I don't care. Still becoming red. So in particular, you see that the red is closer to you than the white, which is closer than the next in the order, closer to the next one, and so on. Here's another, and here's an example where you definitely have such a good order, always. And again, it's not unique. I don't care between this window versus this window, which one should be earlier. But if two windows have a common point, one you see there in their projection there is a point in the intersection, then the order definitely matters. But here it's just the z-depths of this window, and why can you use it for windows? Because they are all orthogonal to the directions that you are looking at. So we are not running into strange cases that you'll see in a moment. Another example, I want to render an opaque cube. That's the furthest away face of the cube. Here is one that is a bit closer, one that is a bit closer. So far the order didn't matter much. One that is a bit closer that I rendered, and by doing so I override pixels of this one that was furthest away. One override once again, and that's how I created it. It's opaque, and you see the three-dimensional part because it's clear. So it also related to topological sorting that we might discuss in algorithms course, that between two objects you might put an arrow. You might say, I'll create a graph and this will be a directed edge of this graph. Why? Because it turns out that these two objects share the point in their projection. So the order between them matters. One is closer to you than the other. For example, A should be rendered before D is rendered. It doesn't necessarily describe a unique topological sort, but once you have such a graph, well, it's better be, you should have a way to explore this graph in topological sort, one after the other. You can use such direction graph to scale, mostly in schedule of projects, when you're saying what should be happened before what. And that's when it works, it's called a DAG, directed acyclic graph. And here are the example where it doesn't work. Well, between the red and the blue, to convex object, it's clear that red is closer to you, so it should be rendered before the blue, which in turn now is closer to you than the green because they share the pixel in their own, but the green is before the red. So when I draw the graph of these three objects that you just saw, these three triangles, it would be A that needs to come before B, that needs to be rendered before C, that needs to be rendered before A. So that's not a directed acyclic graph. It's directed, but it has a cycle. And that's why I don't have a way to use the painter algorithm for these objects. At least not directly. I'll have to suggest a way to splice, to split objects in some meaningful way, like if I want to render these three objects, I can do it if I'll just chop one of them, one here will be enough, and now cut the red in the middle, and you are between the two reds. You can break it and break the cycle in this way. Which brings us naturally to one of the many big family of trees called binary space partitions. So binary space partition has many applications, and maybe one of the cutest is indeed the painter algorithm. They're closely related. So binary space partition is hierarchical data structures, one of quite a few that we are going to see. So in each one of these data structures, just to give you a promo, it's absolutely impossible. Lost it, sort of. Better napkins. Yeah. Every node is associated with a region R of V. Let's write it again. R of V subset of R3, if we are three-dimensional R2, two-dimensional, and V is also stores a line or a plane used to separates its children's R of V dot left and R of V dot right. It's fine if you're confused from it. We'll talk more about other ways for hierarchical structures like quad trees and R trees will be other examples. But let's see already what happened right here. And maybe I'll write it down. The region of the root is the whole the whole space if I'm in 3 dimensions, the whole plane if I'm in 2 dimensions. So the root says, you're asking the root, what is your kingdom? and here the root will say, I'm in charge of everything. Everything belongs to me. The whole plane. And then I'll ask the root, how do you want to separate between your two children, binary tree? How do you separate between them? And it will say, I'll store a plane in 3D or a line in 2D. And this will separate my left child from the right child. One child. Everything on the left child will belongs to one of my children, every on the other side of this line will be for my other child. So the root of this BSP, let's tell you what this B is stored for. I have a set of objects here, object 1, 2, 3, 4, 5. And I build a BSP for them. And the leaf will be the object, but it's not a one-to-one correspondence. The same object might have appeared a few times. How does it work? I'm going to the root asking it, what are the objects that you are in charge of? Root says, everything in the plane. Everything is mine. How do you separate between your children? Each one of your children has its own kingdom, direct children, not descendants. Direct children, how do you separate them? We'll say, I'm using the line L1, or the plane H1, that separates between everything to the left, which in our case consists of the object O1, O3, O2. O1, O3, O2 are all going to one of my children, and to tell you which one. And the other objects, that is everything that is below this line, go to the other subtree. So, sanity check. What's the origin of this node? What's the origin of this node, did we say? Origin of the root is everything. The region of this node. The difference between the region of these two nodes is that they are on different sides of the half planes that the parent stores. And that would be recursive. So one of them is everything above the line L1. One of them is everything below the line L1. But now each one of them need, yeah.
So when deciding what goes above and below, do you have like a normal to your plane or line, and then just decide that, or how do you decide?
Usually you'll say, when I specify the plane, I'll specify the normal, and I can specify the normal above or below, and we'll have the agreement, want to be consistent with the slide, that everything below L1, everything below L1 is on the left, everything above L1 is on the right. I think that's consistent. Now, here is where the confusing part comes. Remember, each one is associated with its own region, which is so far a half. This node, the right child, has to split its region between its two children, always two children. How would it do it? Also using a line, okay? But so this guy, this node, splits the region between its two children using the line L2. But the line L2, well, it's infinite line, except that this node has only this half plane as its kingdom, so the effect of the line L2 just to reach until the boundary of its own kingdom. We don't bother drawing it. The line is infinite. The line that we don't need to know what the boundary of the region, what is the boundary of the line. But the line has no effect when we are going to the other subtree. It's only effect over here, so I am stopping this line when it hits the boundary. Just don't render it. Okay, so I'm using the line L2 when I hit the boundary of the kingdom, and I draw it so I at least separate the two objects, O2 from O3, O2 from O3, but in this case I did it in a somehow clumsy way. So what about O4? 04 is shared between the two children. How did I go to yeah, I got to L2, L2, yeah, O2 and O, the object O1. Maybe I could have drawn the BSP differently, but O1 is inside both children. That would be the part of the splitting that the BSP suggests, means I have. But at the moment I just say both my children have to store, have in their responsibility O1, shared between them, O2 going only to one child, O3 going to only the other child. So now L5 splits between O1 and O2. Again, draw it only in its own region, that's where it stopped, right here, think about the hierarchy of the object, and so on. And we will visit this structure once again. Do I guarantee that it has only n leaf? Not really. If I didn't split anything, then when do I stop this splitting? When I have a single object in a leaf. When I have a single object to a leaf, then I don't need to split it any further. Do I guarantee that it has logarithmic height? Not really. Do I guarantee that it has only n leaf? Not really, because I might need to split things. Algorithmically, what should I do? What makes a good BSP? Well, it's a bit hard to design, so what are we doing when we don't know exactly? We already went to this stage, I think, last meeting. When we don't know what to do exactly, we will take one of the objects at random, each one with certain probability, shoot a ray through this object, and that helps us break it. And now you're splitting all the objects to one side, all the objects to another side. Some are still shared between the two halves, and keep on recursively. And that can work. Here's another object of a BSP, even though it has 4 children to each one. That's quadries, again, something that we'll spend quite some time discussing. Now I split exactly in the middle and of my scene, if I need to, and this line split everything from the left everything from the left to and everything on the right. So I can make a quadtree that usually have 4 children to each node into 1 grandparent, 2 immediate children, and 4 grandchildren. So it's, if I want to see it as a binary tree. Doesn't matter. Okay, so we mentioned the cases that there is a good order. We mentioned the cases where definitely there is no good order. The DAG over here, only 2 shapes over here, but they are not convex. Already suggest which one should I render before which one, not clear, no good answer. So definitely if they intersect, no good answer. Let's ask the visibility problem. I have some viewpoint in all the objects, and I want to use the painter algorithm, and I don't want to start thinking if there is a good order or not. I want to do some pre-processing, invest some time in the pre-processing, and then once the viewer move from one point to another, I'll have a quick way to use a painter algorithm. Don't need to sort ahead of time. And again, the viewer can teleport from one viewpoint to another. So, what should I do? There is a BSP. Build a BSP on all the objects. And the moment I'll assume that I can do it without splitting any object. Here is an object that here is the first line that I create. That's what the root stores. The root stores this line. And now I'll tell you that the viewer is where my hand is. What can you say about the order using the BSP? The BSP here is a line, the plane or line with the root stores. A and B are from one side of this subtree. C, D, and E are on the other side, and my I is right here. Which of the subtrees should I render first? But you first need to check where is the I is in the image. I think that I have this animation. I first need to decide where is the I, just different location. Now, there are two subtrees to the root. One refers to D, E, C. One refers to B and A. Which one should I render first? The one further away from the I. So, if the I lies in the side that belongs to AB, start rendering from the object CD. At which order should you render these only three objects? Well, the BSP continue recursively. You're repeating the same decision for each and every node of the leaf. Start rendering the subtree that is further away from you. If there are any objects on the line itself, render them next. And now move and draw the object in the subtree closer to the I, which are A and B. At which order should you render them? Well, the BSP continue. There is a line 1 that separates A from B. Decide where the I is. Render the 1 that is further from the I, making it B, and then render A finally. So each time when I'm visiting a node, I'm deciding I'll go first, look at which side the I is, go to the other subtree, render all its objects recursively, going back to the root and visiting the other subtree, and recursively doing it all. Okay, yeah, just repeating the same slide twice. And render all the objects in the nearest subtree. After you rendered all the object in the subtree that is more remote from the I. People that did not take computational geometry with me, there are a few, we saw that there are some cases that there is no clear order, which means that I cannot find a BSP without splitting. But if there are BSP without splitting, then there is always a good order, no matter where the I is. That's just the algorithm in the previous slide. If you have BSP without splitting, then no matter where the I is, the painter algorithm will succeed to render it well. There is a good order of the object. If there are splittings, probably the BSP will run into problems. I have to split some objects. Okay, I'm missing a slide. Let's see. So, can you render? I need to see 3 segments on the whiteboard. So I'm down to 2 dimensions, 3 segments on the whiteboard at which I cannot find a BSP without splitting. 3 disjoint segments. Huge puzzle. obviously, if I have two segments that cross each other, then if I try to render BSPs, then I cannot separate them without cutting one from the other. There is no line that separate one from the two. But here the question is about three segments that don't cross each other. Let's warm up a bit. This example, S1, S2, S3. Can I have a BSP or not?
Actually, yes.
Here is my first line, L1, that you can see in dirty white. Split S3 from these two. And now the next line, L2, well, it doesn't split S3, it stops it. This line only affects its own kingdom. So it has no effect. So that will be a BSP for V3. So this is not a good example. Yeah.
We're allowing our our planes to be parallel to each other, right?
Happily, yeah.
Okay.
I think I got it. It's like a. Should I just try it? It's like a. It's like a delta, but like that, maybe.
Perfect. Agreed? Where do I start? Where my first line do I should? Right, in this case. I cannot separate this guy from the other two because this line will split this one. So, very nice. Yeah. When you need recommendation letter, remind me. Okay, let's move to the Z buffer. Like here, so, and the Z buffer, by the way, yeah, it's not disjoint from the BSP. Right, we talked about large scene and we saw a bunch of trees. And BSP can help us navigate between what is further away, what is closer. And the Z buffer can tell us when we want to ask, do I see something at all, or is this visible? I can encapsulate everything by a big box, and there are various tricks. So it's not one or the other, but at the moment, let's talk about Z buffer as a by itself algorithm. So basic idea here is that hidden surfaces removal, if I'm trying to understand algorithmically to realize for each polygon, each triangle, which pieces of the triangle are occluded, which pieces are visible to you, computationally, it's absolutely a nightmare. Unless there are extreme cases, if you have a good reorder direction, then maybe it will work, but otherwise, it's if I cannot use if I need to really start splitting object using the BSP or using other methods, it's polynomially I could end up with ridiculous number of sub-slivers. And what's the deal? Most of them are not visible at all. I'm working very hard for something that are really not in the level of visible to the viewer at all, or not makes any difference because there are pixels involved in something that is sub-pixel maybe doesn't matter at all. So the idea, I'll solve for every pixel, it will decide for itself what will this pixel show. And it's nice because it asks to be parallelized to start with. Every pixel will take its own decision. But at this point, I'll assume that all the projections that I'm doing are orthographic. All projection directly on the camera. So only and I'll assume that the x-axis, that the x-axis, y-axis, and z is a depth. further away from you, the smaller z value or the larger absolute value. Smaller, but it's negative number. So then I'm not worried about such cases. Might be complicated, but each pixel here will make its own decision. And the idea is that I will go over all the objects. Of course, I should be a bit smart about what are all the objects. But at the moment, I'll just assume for all the objects, I'll go over all the objects, and I actually need 3 buffers, 3 arrays. One is called the color array that will eventually show you the final image. You see. The other one is called, that will be the depth buffer that tells you for each object how far away it is from you. Usually, when you're talking about grayscale, the larger the number is, the more white it is. So things that are very far away from you, completely white. Things that are very close to you, completely black. Looking at the absolute value of the depth. So larger Z further away, and you see that objects that are closer to you are just darker. So I need these 2 arrays, and that's the only thing that I need. Okay, and that will help me render fancier things like this. So for this fancier shape, this will be the depth buffer that also. And you can absolutely ask OpenGL to show you what is a depth buffer as an image, just called it. It's just a normal file of bytes. Every byte is a depth, every word is a depth. So just show it as an image, and that's how it's becoming great scale. But it's just a number. And here is a whole Z buffer algorithm. Z buffer of the whole C will say, for every pixel I, X, Y, do put the maximum for this, initialize it to be as far away as possible. Okay. And now, for each polygon, each triangle, I will project it. It involves maybe move it, translate it, put it in the right place, so it's only orthographic projections that I need to do. And for each pixel xy inside this triangle, it has its own z value, which I'll have to tell you what is its z value of this triangle at this very peak point, this very pixel. This triangle is not necessarily orthogonal to the viewpoint, so different points of the triangle might have different z value, obviously. So I need to ask what is its z value. And here is the cool part. When does it affect the color of this pixel? Only if this value that you got is smaller than the value of the nearest object that you had. If it's closer than the nearest object that you saw along this pixel, that is, you are shooting away from you through all the pixels, and you are just marking for this pixel what is the nearest object that you have seen so far for this particular pixel. When should you change the color of this pixel? If the z value that at this very pixel is smaller than the previous nearest object close to you, then do 2 things. First, change the depth value at this very point because it has a new minimum, new closer to you. And in addition, what is the color at this point? Well, compute the color, which might be color of the object. It's more just ambient or any shading effect. Put it all in the color and assign it to this particular pixel. And do it for all the pixels at the same time, and that's all you need, as long as all the objects are completely opaque, with no reflection. Yeah?
What will be the input scene be like? Is it like a bunch of list of polygons, or is it like...
Yeah, list of polygons, each one with its own color, or color at least of the vertices, and then we need to interpolate. So, yeah. So, here is the image that we saw, and we can push, there is no BSP involved, no specific order of the object. I just pass over the object at some arbitrary order. Of course, I can do better or I can do worse, but the vanilla algorithm is put each one in its own time, arbitrary order, place start from the one, and now you are changing the depth color as well to be the color of triangle one, just because arbitrarily I started from triangle one. Moving to triangle two, the one closer to you doesn't affect much anymore, no interaction between them. Putting triangle 4, for whatever reason, that's the next one. And now you see that triangle 4, at the pixels that are already covered by triangle 2, that is closer to you, I do not change the color. At the other pixels of triangle 4, which has the default value, which is infinity, you see all the way to infinity, triangle 4 is closer to you, so you're changing the color, but not to change the color of triangle 4. And of course, you're updating the depth buffer to be just the minimum one, didn't affect 2, but affect the default of the other triangles. And finally, triangle 3 that comes now, change the color of a few of the triangles that are closer to it, but doesn't change the color of the green, of the red one, triangle 1, because triangle 1 is closer to it. And again, it's pixel by pixel decision. Okay. Let's talk a bit about restoring. How can I compute what is the depth that you see from the pixel? Well, I need barycentric coordinates. You know barycentric coordinates? We can so we know barycentric coordinates. I have the depth at this vertex of the triangle, say its depth is 0, the depth at B, say it's 50, the depth at C, say it's 100. I want to ask what is the value at P, and I need to compute the area of these three triangles and compute the contribution of B would be the area of, for B, the area of the triangle that doesn't include B, this one, divided by the overall area. And now I want, yeah.
Do we have to recompute?
That's exactly what I'm doing. And now that was for one pixel. Remember why I'm doing it? Also, it will be in the color when I want to blend different colors, but to start with, because this is a planar object and barycentric coordinate, just tell me what's the depth, how far for this pixel in that triangle is away from you, given that the vertices of this triangle and the triangle is part of a plane. So that's doable, and maybe if you have enough parallelism, that's exactly what you'll do if you want to get the answer for each and every pixel all at the same time. Probably you have a lot of processes, but not enough to fit all the triangles, or you can better use them. Instead, do the following. What did we say? How can we interpolate when the point P that we ask is on the edge? Barycentric coordinates just boils down, the points are on the edge, boils down to linear interpolation between these two edges. So I first compute the values of all the pixels along this edge. Linear interpolation, I'm moving from z equals 0 to z equals 50 in, let's say I have 10 pixels. Over here, compute the value for all of them. And let's do just linear interpolation between. Similarly, I'll do for the other edge between A and C. And now I want to compute what are the depth value of all the pixels along this edge. This edge, for conveniently, I picked it to be parallel to the edge BC. Among this edge, I'm going to compute the value of all the pixels and then move one pixel to the next row down, next row down, next row down, and so on. And how can I compute the values of all the pixels along this row? Well, I'm going to do linear interpolation, which is already simpler than area calculation, but I can even do it simpler because once I look at the length of this row and I know how many steps there are, then things are changing linear, meaning that from this pixel to the next one, I'm just adding a constant. Adding a constant, adding a constant. So you're computing one constant for the whole row. It will be different to the next row. Start from this value, compute for the next one, the next one, the next one. And that sequentially, it's just additional operations, which are much quicker. And if you have parallelism, do it for a lot of rows at the same time, or a lot of triangles at the same time, and so on. So that's a rastering process. And you'll do exactly the same way for colors or any other properties. And that's how the rastering is done. And that's, by the way, how the OpenGL will do it when we'll move to shader programming, when we'll actually ask you to write a little program that every vertex decide about, every vertex of a triangle, and a little program that every pixel by itself needs to decide about. And that's essentially all you need to give when the scene just shows itself. Thank you.
For the program, because I'm doing in C++, can I use a library that reads JSON files?
Yeah.
Okay.
Yeah, convert it into an array? Yeah, I didn't mean it to be anything else.
Well, I meant like you're giving us a JSON file for all the objects, right?
Yeah, if I didn't provide this library, sure, you can use because in homework 3, I'm adding more properties, and it didn't mean that it should appear that the database automatically to upload. Yeah, you'll find the libraries that upload JSON files. And thanks for telling me, and make sure that it's.
Well, I meant because I was using C++, so it might not.
Yeah. That's fine. As long as you're doing the ray shooting, how you're getting the array of the each board and each item. Sure.
I'm using Python NumPy for the homework too, and I think whatever the animations, if they don't come up properly, then I'd be like losing points, or if I'm not using some parts of.
So, and you, I'll just tell everybody, and you might as well already. I have a homework 3, or I didn't. Homework 3 will be just. So I'll tell everybody, homework 3 will be similar to homework 2, except that there will be reflection and shading and mirrors. And so I'll put it out today, and you can take a look and plan directly to it. It's mostly including homework 2. So it just, so animation?
Yeah, any animation or something, because I didn't submit the homework one because I had chosen to drop it because I didn't finish the Python related work. So, I didn't finish the JavaScript related transition from the Python. But in homework 2, I want to just use Python because I think it's much more faster for me. So I'm using Python JSON reader, and I'm populating it into the NumPy array and extracting the UV, like the ray tracing, to calculate the ray tracing and everything explicitly.
The only difference is that array should be array, and you should do slowly. How do I find if array hit a triangle? You cannot use any library there. It cannot be more clear. Your array is a vector plus, or where does it direct? You have to compute the times that array hits each.
In JavaScript, there's an opportunity to see the image that is loaded, but in Python, I don't have that kind of a medium, so I have to load it, see the image, and then access the array in such a way that I can access cell by cell, and then calculate and apply the transformations.
If it makes a difference, sure, go ahead, but you can use a checkboard or constant image in all the steps until you actually start to get it. But whichever, as I said, if you want Python, and you want to use library to read JSON file and later it will be object file, absolutely, there is no point of view parsing the part. It's and vector multiplication, matrix multiplication, go ahead. But nothing above this level.
Okay, thank you.
Or if there is any doubt, ask me.
I just wanted to ask if for homework 2 would be possible that I turn in on Friday or Saturday. Yeah, just because like tomorrow I have an exam and I was really stressed.
I'll give extension to Sunday. I don't know if I should, but
because I think I understand. So obviously, you know, when you're doing this, you have your linear algebra model. You translate the JSON stuff into some like storage system for like 3D coordinates, and then when you're doing the rendering.
Just to make sure, you have a library that reads a JSON file and spits out an array. So you want to call it list of objects, and then you can ask if this object is of this type or that type, or it splits two arrays, one for spheres and one for billboards.
I have a structure class that manages that for me. But so just to make sure, when you're actually doing the ray tracing from the camera, this plane, is it, so you're ray tracing from the camera, does the like ray follow the same angle that it came from the camera, or does it trip out from the ray space?
It's the same direction. You're basically solving the equation of I generated this list of pixels in the image. So that would be P1, P2, P3, and so on. And now I move to the side. Here is the I. Here is P1. I'm shooting the ray I plus. I'll start by creating the vector V1, which is P1 minus the I. Probably want to normalize it. At the moment, at least it's in direction. Now I have the ray I plus times V1. And next, I'm asking at which time will this ray hit the plane that contains a billboard 1. And it happens at some time. There's almost always a solution to this equation. In case that there is no solution, it's just if the plane is parallel to the vector. Otherwise, there is some time. You're checking this time is negative, meaning that it's happened out above the eye, ignore it. If it's positive, you're saying, okay, that's a candidate. Let's check if it actually hits a billboard, which is a different episode by itself of the UV and the inner coordinate system of the billboard. So, did not hit the billboard. If it did not hit a billboard, it's not a candidate. At the end, I'll see a few billboards that the ray did hit. I'll ask him among all the ones with positive line, because as we said, negative backward, what is the one that is the closest, that the time is minimum, and that's the one that I retrieve the color from.
And then, because alpha is also stored, you can also just check if the, like this one, its alpha value is, I can't remember.
Absolutely.
If it's like, you know, not, if it's transparent, you look at the next one.
That's, it's multi-step process, but nothing. Every step is clear. The one that I found most confusing is to move from to use this UNV both to check if I hit the billboard at all, that would be the alpha beta if they are between 0 and 1, because if they are larger than 1 or smaller than 0, I miss the billboard. If they are both between 0 and 1, then I can use them to jump immediately to the pixel in the billboard and retrieve its color.
Thank you.
Sure. Hey, finally, I know that.
I'm sorry. I have way too much on my plate right now.
just double check with my son because I told him all good.
Okay, I just want to show you if it like looks fine, like if we were supposed to do this, because I try my best to understand the directions. Since it starts at like the base size, I only did a 2 in the beginning, and then I did a 4 from here on out.
I'll take a few points. Don't think that the spec said that maybe it shouldn't go out from the frame, but it's probably okay.
Like out of the frame?
I think that at the beginning we saw a piece of the bunny, but I don't know if it's at this point, if you should waste time.
Like what
I just don't remember what the spec said. Original, if I ask to keep it inside the frame, it just is matrix that I called scale 3 that one of us has a mistake with it. Originally it gets out of the frame, but maybe I didn't limit it. So whatever it said. But other than that, does it work for other files? Or just for the bunny?
I haven't found another PPMM image that works, because like this one I think is like a binary file or something. And the ones online I found have just been like PPMM files with like that.
Okay. Since it's homework 1 and we're already so late, it's either fine or almost fine. I will
Okay.
not.
Because, I don't know, I tried understanding the directions.
It seems that you understood and you have all the pieces that I asked for.
Okay.
So submit the video and submit the code, and hopefully the code is readable.
Okay.
And,
I commented
I'll make noises if I cannot understand what's going on.
Okay, because, yeah, I didn't know what was meant by the display window should be larger, because I thought, based on here, that it was saying, like, if it's 100, like, if it's at its max size, then you should only see a certain amount of it in the 600 by 600.
That's fine.
Okay.
You showed the thing that I wanted to see, that you handle. That's as much as I can. I will try not to take off points for stupid things. Points of importance, you don't leave empty pixels, you're going in the right direction of the transformation, the use of the matrix is fine. You're always taking the input from the source image, right? You're not doing incremental changes. Like, some people make a mistake to move from t equals 0 to t equals 1 by rotating by 5 degrees. The next frame should rotate by 10 degrees, so I'll take the first image, the second image that I created, which is by 5, and rotate it by 5. And if that's what you're doing, then it usually accumulates some difference. It's always a transformation from the input file to the output, not referring to the history. Okay, yeah, that's good. So, yeah. And you can make a video out of it one way. Yeah. Submit, and that's probably fine, and start homework 2 is, I'll give an extension, but I assume that,
yeah.
Do you have any questions on homework 2?
I need to look over it still.
Okay.
Yeah, I'm behind right now on a lot of things.
As soon as. And if there were more reasons, then make noises. If there are more reasons to delay, I don't need details. But Yeah, but at some point I would like to say that's a real deadline. But at the moment, yeah, it's a week. Try to finish by the weekend.
Okay.
Okay, thanks.